Hello, today we're going to be talking about ellipses, how to find the standard equation, and how to find some of the properties. So this will be an example of an ellipse. There are different parts to the ellipse. First one, we're talking about the chord. So the definition of a chord is going to be the same one as the one for a circle. You're going to have a line segment that starts at one end point of the ellipse and then ends in another one. There's two special chords. The first chord is called the major axis, and it's going to be the longest one out of all the chords. The second one is going to be the minor axis, and it's going to be the shortest one. Half of the major axis is going to be the semi-major axis, which is going to go from the center to the end point along the longest side, and the semi-minor axis is going to start at the center and end on the shortest axis. There is two standard equations for ellipses right here at the top. The first one, x squared over a squared plus y squared over b squared equals 1. The second one, y squared over a squared plus x squared over b squared equals 1. If you notice, the equations are basically the same except for your a and your b being in opposite sides. A is always going to be the larger number, b is always going to be the smaller number. So basically, if you look at them, the first one has a squared over x squared, and the second one has a squared under y squared. So that will determine the direction in which your ellipse is located. So if your a squared is under x squared, it's going to go horizontally. If your a squared is under y squared, it's going to go vertically. So we are going to talk about the first one. So if your equation is x squared over a squared plus y squared over b squared equals 1, your equation will match this graph right here. So to find vertices, all you have to do is find your a and then put comma 0. You also have to do negative a comma 0 to find the second one. Same thing for your b's. 0 comma b and 0 comma negative b. Notice how they're opposite on the other one. So your a is here vertically, your b is on the horizontal line. Your origin will always be 0, 0 for this example, so that's never going to change, but it will change in the future. Keep that in mind. The only thing we're missing is how to find c. In order to find c, we're going to use the Pythagorean relation that's listed. Notice how it's the same one for both, but it's different than Pythagorean theorem because now we're going to say a squared equals b squared plus c squared. When you look at it, you will see that you always create a right triangle on both. A is always going to be the hypotenuse, B is always going to be the semi-minor axis, and then C is going to be the distance between the center and the foci on both. As you can see, you have two foci, always one on the left, one on the right if it's horizontal, or one going up and one going down if you're vertical. So let's do one example. We're going to convert from this to the standard equation, and then we're going to practice how to find foci. So this is your first example. 4x squared plus 9y squared equals 36. Remember, we want our equation to be x squared plus y squared equals 1. So in order for us to make this equal to 1, we have to divide by 36. Whatever you do to the right side, you also have to do it to the left. After you do that, all we have to do is simplify. We want this to be x squared, but it's 4x squared, so we need to divide the top by 4. We also need to divide the denominator by 4. When we do that, we do get our x squared at the top. Now we have to divide 36 by 4, which will give us 9. Same thing here, divide the numerator by 9, divide the denominator by 9 as well. When we simplify, we get y squared over 4 equals 1. We are almost done. All we have to do is rewrite 9 as 3 squared and rewrite 4 as 2 squared. We notice that a is equal to 3 and b is equal to 2. Again, a is always the larger number, b is going to be the smaller one. So now we know that our ellipse is going to go horizontally. And it's going to go 3 units to the left, 3 units to the right, 2 units down, and 2 units up. I'm going to do a very rough sketch of my graph. Now we're going to look for some of the properties like vertices. So your 2 vertices will be here and here. So negative 3, 0, and 3, 0. We're going to write the covertices, which will go here, 0, 2, and 0, negative 2. So now all we're missing is the foci. Remember your relationship, a squared equals b squared plus c squared. So a is going to be equal to 3. Then we have to square it. B is going to be equal to 2. We have to square it. And then c, we don't know. That's what we're looking for. So that will be 9 equals 4 plus c squared minus 4 minus 4. So that will be c squared equals 5. Take the square root of it. So c is going to be equal to the square root of 5. So remember, your c is always going to be along the major axis. So I'm going to highlight it, which is here. So your foci will always be between the center and the vertex. So we're going to convert square root of 5 as a decimal just so we can get a better approximation. So I'm going to go to my calculator, type in the square root of 5. Number, and I want to approximate to a decimal. So it's about 2.23. So a little bit over 2. So one of my foci will be there and the other one will be there. And I'm just going to label them individually as focus. I am going to leave it as negative square root of 5, 0, and positive square root of 5, 0. And I'm basically done. I gave all the information that they wanted. I wanted to do a sketch of the graph, give the vertices, covertices, and the foci. This is another example. So again, we want it to be equal to 1. So divide by 144 both sides. Now we have to simplify by dividing by 16 on the numerator and divide by 16 on the denominator. When we do that, we're left with x squared over 9 squared. Same thing here, divide by 4, divide by 4, so then we get y squared over 36 equal 1. Should just be 9. I wrote 9 squared. Now, I'm going to rewrite that as x squared over 3 squared plus y squared over 6 squared equals 1. So now your a is here, so a is equal to 6 b is equal to 3. Again, remember a is always a larger number. So now we know that this graph is going to go vertically. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then to the right, 3, to the left, 3. So now we're going to sketch a graph. Again, very rough sketch. So now I'm going to find vertices and my covertices. So now your vertices are going to go up and down. So it will be 0, negative 6 and 0, 6. Your covertices, negative 3, 0 and 3, 0. So again, we're still looking for the full sign. So in order for us to do that, remember your equation. A squared equals b squared plus c squared. Plug in your values for a, which will be 6, and then you're going to want to square it. Plug in your value for b, which is 3, and then you're going to square it. And then again, c, we don't know. 6 squared will be 36. That will be 9. 43 squared, and then you have your c squared. Subtract 9 from both sides. So then that will be 25, right? No, 36 minus 9 will be 27. Take the square root on both sides. C equals the square root of 27. So now, remember, one of them is going to be positive, one of them is going to be negative. And we are done. If we want to do the square root of 27 as a decimal, square root of 27, menu, approximate to decimal. Sorry. Menu, approximate to decimal, and it will be 5.12. So again, we're going to come in here and we're going to mark it. And we are done. So now there's some examples for you to practice. So notice how some of them are already in standard form. Keep in mind that when you rewrite this one, you're going to change this to 4 squared, but then you're going to keep this as the square root of 7 squared, since you can't take the square root of 7 and get a whole number. Same thing for all the other ones. When you work with your a and b, then you're going to say this is a, which is 4, and then your b is going to be square root of 7. So keep that in mind when you are working with them. Thank you.